All right, so let's say we're looking at these, and I asked you to find angle B, find angle C, and find side A. All right, if you're working through to locate the remaining pieces of this triangle, you first need to identify the pattern of information given, so two sides and the included angle. So once you do, SAS is one of the patterns that fits law of cosines now. Okay, so this tells us we're going to be using law of cosines to solve this. Okay, and so since you're given SAS, remember this piece is always going to be one of the extremes. Okay, it's always going to be either or in this case, if it's an angle, it's the last piece. If it's a side, it's the first piece. Okay, so in looking at this, what we know is that here's our first and last piece, side A and the angle opposite it, angle A. So the way that I'm going to set this up is I'm going to set it up as A squared is equal to the sum of the squares of the other two sides with a slight adjustment, and that adjustment is minus twice the product of those two sides, all times the cosine of the angle opposite that unknown. And again, if my angle had been the unknown, then that would go at the end here, and I'd start with the side opposite that unknown angle. But again, one of these two, one of the extreme pieces has to be your unknown, what you're solving for. Okay, and so now it's, again, a nice easy calculation here using your calculators. You can apply the solve feature. So the F2 algebra tab, type in our equation. I'm just going to use my x instead of a to save time typing it. So I enter my equation exactly as it appears. So it's the sum of the squares minus twice the product of those two sides, all times the cosine of the angle opposite that, and I'm solving for, in this case, x. Okay, so as I wrote this out, I didn't include any decimal points, so I need to use the green diamond button to make sure my answer is in decimal form. Okay, and once again, I can make a prediction here. I'm looking for a side. Okay, do I know whether this side is the largest, smallest, or middle one? No, I don't know. So I can still have a prediction, though. It has to fall within what two values? Has to be greater than the difference of these. 2. So it's greater than 2, but it has to be less than the sum of those, 22. So we know it's going to be between 2 and 22. Again, it's a huge range, but that is the only prediction we can make. And what I see here is I get the side length to be 4.3 approximately. And once again, if you look at the display, you have a positive and negative. Since you're dealing with perfect squares here, that should make sense. All you need to do is deal with the positive of them. The negative one is not going to be used as a distance or length here. And now, here's a suggestion I would make. You are going to be using this length later to do some calculations. So what I would suggest you do is get this measure alone on a display line so you can refer back to it again. So if you highlight this whole thing, this whole line, and then hit enter and delete the negative value, and then I'm going to jump to the front. I can jump to the front by hitting second and then this directional. It'll jump me all the way to the front, and then delete the x equals. Now I'm just going to hit enter, and all that's going to do is it just displays that value in its own line, so that if I want to go back and refer to it in a later part of the calculation, it's going to be easier and I won't have to delete the x equals then. Now, you don't necessarily have to do this step, but eventually you'll have to delete all the x equals and the negative value, so you might as well do it now. All right. So now, in looking at this, Patrick, question?
So if you get the two sides up there, 10 and 12, does that automatically make the numbers next to the 2, 10 and 12? So if what's in the equation you gave us, is it
Oh, this one here? Yeah, this will be the two sides.
Okay.
This will always be the two given sides. All right, so in looking at this, we found side A. Now all we need to do is find angles B and C. So you have two choices here. If you wanted to, you now have a pattern of SSS, which means you can use law of cosines to find your next angle. But you also have a pattern of SSA, right? 4.3, 12, and 20, 4.3, 10, and 20. So you have a choice. You can either use law of sines or law of cosines. If you use law of cosines, the negative is it's often a more complicated calculation. Okay? But the positive is your answer is going to be accurate. You don't have to think about it. You can do either of them. You can either solve for B or solve for C. And now, law of sines. The positive is it's an easier calculation to set up and to enter. The negative is, because the pattern we're referring to, SSA, if you don't choose the right angle to find first, you might actually be finding the wrong triangle. Okay? And so there is a really easy way to determine which angle to find first if you are going to use SSA, and I wanted to talk about that here really quickly. Okay? So the whole idea of SSA is that it's possible that you find a triangle that has an obtuse angle. And so if we can eliminate that, if we can make sure that the angle that we find is not obtuse, then we're good. So which of these two angles, unknown angles, B or C, is it guaranteed will not be obtuse? Which angle could you guarantee me is not going to be an obtuse angle? C, right? Because C is opposite a side of 10, B is opposite a side of 12, so the only one that could possibly be obtuse is B. So if you choose to find the angle that you know will not be obtuse, and then that works just fine. Law of sines will go through with no problem. Okay, so I'm going to use law of sines to find angle C. Okay, so if I start out with my unknown, sine of C over 10 is equal to my known ratio, which is now, it's this value of A, which I found, and this sine of 20. So I set up that ratio. I'm going to solve it. Again, your calculators cannot do this calculation on its own, so you have to use a substitution. Okay, so we're going to let x be sine of c. I'll make that replacement here, and I'll solve for x. Okay, and so using the solve feature, the F2 algebra tab, choose solve. X divided by 10 is equal to sine of 20 divided by this value 4.3. So here's where, if you didn't enter it on a display line by itself, you'd have to go up and get rid of all the x equals at this point. Okay, and we want to solve for x. So prediction-wise, I'm solving for a sine or cosine ratio, so what do I expect this number to fall between? So -1 and 1, when I hit enter, it fits that description, so I have 0.7957 is equal to the sine of c. Therefore, angle C can be found by taking the inverse sine of that ratio. And so if I calculate the inverse sine of this ratio, and now once again, I can choose to either leave the x equals or delete it. I'll always delete it. In this particular case, you could probably leave it and be fine. It'll just have x, there'll be an x in your answers, it'll be an equation form. But I get my 52.7 approximately for my angle. And now once I have that, the last thing I need to do to solve for B is to just use triangle sum. I get 180 minus my given angle of 20 minus the angle I just found. And that's going to leave me with 107.3 as my final piece.